Good morning, everyone. Good afternoon. Maybe good evening to a few of you. I am Jeff Blankenberg, and as usual, we are here with an episode of Alexa and Friends. With me today, I have the great honor of having Andy Breen joining me. He's the Senior Manager of TTS Research at Amazon. Thanks for being here.
Hi, glad to be here.
I'm glad you could be here too. As we usually do in these interviews, one of the first things that I like to start with is some silly questions, and I know I've prepared you only in that there's going to be some silly questions, but I certainly haven't told you what these questions are. And so we'll start with the first one, which I always really enjoy. I think it offers some insight into people. If you could choose any one superpower for yourself, why would you choose it, and which one would it be?
Okay. Do you know what? Strangely, I do think about this now and again.
That's good.
But the problem is, I'm just too practical because if you fly, right, if you went supersonic, you'd be burnt to a crisp very quickly, and so you'd have to have more than one superpower if you're going to fly to make it actually practically useful. So I don't know. So I sort of think there's a few I like, but if I had my own superpower, I think it would be the ability to know when to stop something.
Ooh.
I start a lot of stuff. I'm a great starter, lots of great adventures, lots of great things, but I'm pretty bad at knowing when it's time to stop doing something, when it's time to give up. And I can think of lots of occasions where I've watched stock markets go up and down, and I've never known when to sell. So I don't know. You watch them go up,
knowing when to stop, I wonder if that's just kind of like the ability to see into the future a little bit. Because I think the reason for stopping sometimes might be different, right? Is it because I want to sell stock? Or is it just because this project that I think is going to be really successful is end up not going to be very successful at all? So I shouldn't spend the time on it?
I hadn't really thought about that actually. I mean, I was thinking that like I'm a big amateur painter. I love my art, and I've got friends who are artists, and sometimes I'll be tutored by them, and their one comment to me is that they've seen a lot of great paintings come and go because I've just kept working it and working it and working it, and never know when to stop.
Sure. Is that some of your artwork behind you?
Yep, that's some of it.
Oh, that's excellent.
Yeah, that's actually a musician called Anna Calvi, and it was taken from one of her videos. I got permission and I spoke to her, and she was all happy to have it done. And they were really dynamic poses, and I really loved them. So I decided to replicate them in art form. And so I did a set of 3 and had a small show to show it. So it's all good fun.
Very cool. All right, so we're gonna call it knowing how to stop, but I do feel like it kind of translates into future vision of some kind. But I like it. I think that's a good one.
Spidey sense. Right?
I do like the practicality of flying, though. We've had many guests on here that have said flight, and I'd never really considered the fact that you wouldn't be able to go that fast. I mean, you'd be able to go decently fast, faster than a car for sure. But,
sure.
But to go Superman speeds, that's another story.
Yeah, friction gets in the way.
It does. It's a limiting factor. But what if you could go sonic, but of course you have the friction problem. What if you could just duck out into space? You go at a reasonable speed into space, and then go supersonic around the globe where you don't have the friction, and then duck back down, because it'd be supersonic. You'd only have to hold your breath for a few seconds.
Wow.
That's something.
Yeah, but then you would explode with lack of pressure. You need to have the super package.
You
right?
do.
And then flying.
You do.
You just need
all right. I'll let that one go. So I have a couple of other questions, but being an artist, I'm going to see how this one translates for you. Maybe you've given this some consideration. Have you ever been any kind of musician in your art past?
Only a bad one. I do play guitar. I love it. I love playing guitar, and I play regularly just with friends.
This is going to be perfect question for you. This is lovely. Some people are like, no, I've never touched a musical instrument other than a recorder in early elementary school. So one of the questions I like to ask people is, I want you to imagine these people that you're playing music with, that you form a band, and you decide that you are going to release your debut album. What is the name of that debut album?
Oh my God, I've absolutely no idea. Now you've thrown me completely there. No idea what I would do. Uh, I guess, do you know what? This has just literally come to the top of my head. I think I would call it something like reflections.
Reflections?
Um, yeah, only because, I had what people call a significant birthday relatively recently. And even though I don't like recognizing age and birthdays and all that sort of stuff, you find yourself reflecting
Sure.
on things, and I guess I've just been doing a bit of that recently. So it would have to be just
Reflections. All right.
reflections, I guess.
I like that. I think that's a good one. Well, happy belated birthday and welcome to your 40s. Congratulations.
Indeed, yeah, yeah. No, the
All right, so let's also let's wrap up with my favorite question. This is an audience favorite as well, and I like to tell a little story about how this happens. So I want you to imagine you're walking in a busy city, and you need to turn down a narrow alley, and not much wider than yourself, but it's an alley between two buildings. And you start heading down that alley, and as you get about halfway there to the other end of the alley, you are confronted with a horse-sized duck. So imagine a very, very large duck that's about the size of a horse. And it looks very threatening.
Okay.
And so you turn around and you're like, I got to get out of here. And so you look at the other end of the alley now, and there are 100 duck-sized horses. So little tiny horses, maybe this big. They both are aggressive, and to survive, you need to get out of this alley. So if you have to fight one side or the other to get out, what do you choose and why?
Right. Ah, interesting. Interesting. So what's a duck-sized horses and a horse-sized duck, did you say? Yeah.
But a hundred of the
Uh,
little ones.
100 is a lot. See, this is the thing, This is what I'm thinking. I'm just thinking it's a very crowded lane you've
It
got me in
is.
here as well, side alley. I think I'm going to go for the big duck. Now you've got to get past it. You've got to get past the beak. The beak is the
Right.
big problem there. He's not going to be very maneuverable. He's a big duck. He's not going to be able to turn around.
Right.
He won't be able to go backwards and forwards. So I reckon that if I could sort of do a sort of a shimmy and a dirty dive to get between his legs, I think I'd be out and under before he could actually do any serious
I
picking
like
on the
it.
top
I like
there.
almost nobody picks the big duck. I'm really impressed that you decided to go that route. I like it. Almost everybody is convinced that they could somehow get around 100 tiny horses, and I just imagine walking through a beautiful park, big open space, and all of a sudden I'm surrounded on all sides by 100 ducks, just normal ducks. That's intimidating and scary. I can't imagine 100 small horses being surrounding me that way. I think that would be much tougher. I'm with you. I go big duck every time.
Yeah, they're going to get one big peck at you and then they're
Right.
done. But it might be a lethal
It
peck.
could.
But,
It certainly
they're
could
going to
be.
get one peck.
Certainly could be. All right. Well, that's
Yeah.
wonderful. Thank you for humoring me with my silly questions. All right. Let's get into it. The next step that I like to take in these interviews is to kind of talk about your background. So I'd love to know more about a little bit about your role here at Amazon. Maybe end with that. But I'd love to know specifically what your origin story is like. How did you get to Amazon? What led you to the path that you're on today?
Right. Okay. So, well, I didn't start out in speech. I started out with my first degree was in physics with computer physics.
Wow.
So a long way from speech. Although I guess even back then I must have had a sort of innate interest in it because I ended up doing a third year project to create a real-time speech recognizer, which was a little bit out of what they were expecting people with physics to do in the third year. But I enjoyed it. I didn't get very far, but I did enjoy doing it. But I had every intention of staying in physics. But then when I left university, I had a young family and needed to get a job. I looked around. I looked for hundreds of jobs, and I was just very fortunate to land a job as an RA in the University of Liverpool in their speech group, and they were doing speech coding back then and some other speech work. And that was my first opportunity to experience that area, and I started to enjoy it. And then that was a fixed-term contract for around about 3 years, so I had to think about again where I'd head. And I had to decide whether, okay, so, I've got experience now. I managed to get a further research degree when I was at Liverpool. They were kind enough to let me do that as well, in engineering. So that was cool, a new skill. So I had to decide whether I want to go back to physics or stay in this speechy stuff that I'd started to work on. And again, it was just pure luck. I applied to 2 or 3 different positions. Some of them were physics related, and some of them were more speech related. And I was just lucky to land a job at University College London, which is a very well known centre for speech and language is and was at the time. And that was when I really started to get into spoken language and language in general. There were so many great people at that university, and we had so many people from around the world visiting us. So you just have all the great names turning up and giving a lecture on something. So it was a great tuition.
Yeah.
So I was there for a while, and that really got me into it. And actually, I did a PhD there while I was an RA, and that was in neural networks. This is the second time neural networks turned up. They sort of generated in the 50s, and then they were a resurgent in the and then I started to do text-to-speech using neural networks way back when. And that was my original PhD. And then I left UCL and joined British Telecom, BT Labs, as they're known, which is, I guess, similar to what people, if they remember AT&T Labs when it was a monopoly. There were these big research labs that the telcos had a few years ago, and I joined the British version of that. And again, I was just really fortunate. I landed on a research project that was looking at spoken dialogue systems. It was going to be a train timetable system, believe it or not. And in my first year there, I had the opportunity to work with Professor Steve Young from Cambridge University, and he just developed a well-known toolkit called HTK, which was a research toolkit for working with hidden Markov models in ASR. And so that was a real education in itself, just having the opportunity to work with this new kit. And then maybe a year or so later, I moved back into text-to-speech, eventually becoming the lead there. And then as the career progressed in BT, I was given the opportunity to manage some other projects. So I looked at talking heads and distributed dialogue systems, which were consisted of multiple machines communicating together to produce a distributed dialogue environment. And then after BT, I think, I can't remember, it might have been 11 or so years at BT, a while, I decided to go back into academia and became a senior lecturer at the University of East Anglia in the computing department there. And I was really lucky that BT had given me the opportunity to do some work there for them as a contract. So I worked on some research there on AI for a couple of years, and at the same time I was still involved in speech synthesis and still developing synthesis systems. And I started to build a small company, and then ended up collaborating with another company on building and selling TTS systems. And that's when I met up with Nuance, which was a startup, a Silicon Valley startup at the time, and with the intention of selling them my system. But in the end, they ended up buying me in the end. And so I started the TTS arm of the Nuance company, and then I've done many things in Nuance. I did lots of different positions, but always really within the text-to-speech space. And then I just felt it was time for a change, a new challenge, and I was very lucky to get the opportunity to come and work at Amazon. And it's been just a real roller coaster, fantastic adventure ever since I've been here. And it was at a great time. I mean, the technology had just had a new spurt of life. And so I've been riding that particular roller coaster for the last 3 years.
So you've been at Amazon for 3 years?
3 and a bit now, yeah.
I just hit my 4-year anniversary. And I agree with you, man. This has been one of those adventures that I never thought I'd find myself in. I obviously don't have a deep background in voice, but I have a deep background in software development, and so being able to take apart some of the amazing things you guys are building and be able to use those to build really compelling experiences for people, that's man, this has been just quite an adventure for me. So there was a theme in your history that you just shared there, which was luck. You often said, "I was very lucky. I was in the right place at the right time." I personally am not. I'm not a big believer in luck. I believe that we make our own, and I think more than likely you call yourself lucky, but it was probably making the right opportunities, doing the right research, putting yourself in the right positions. Whether you do it consciously or not, I think that's probably what leads to these kinds of great stories. But boy, that was a rich, awesome history. Thank you for sharing that.
Yeah, I'll go halfway with luck. I mean, I think with everything in life, you've got to take the opportunities when they
Sure.
come along. And if you don't, I don't like regret. So that comes back to the first question, right? I'd rather try something and go for it than think, oh, I wish I'd done that. You know, life's too short for I
I
wish.
agree. 100% agree. So you've had quite a long tenure in the world of speech synthesis and TTS. What's the thing that's
Mm.
kind of kept you rooted? What can you imagine a scenario where like you would have gone a completely different route in physics or something like that? What would that have even looked like?
That's a yeah, great question. As I say, I didn't really have any intention of moving into the speech and language field. I'd always enjoyed and admired physicists as a child, and they were my sort of heroes. And people like Richard Feynman, who was a tremendous character and a tremendous physicist at the same time. So I guess I wanted to emulate those sort of my heroes at the time. And I was torn between cosmology and the other end of the scale, you know, atomic physics, and certainly enjoyed both those topics. But I never, as I say, you know, whether it's luck or whether there was something in me that drove me back into the speech and language area, I'm not sure. But I guess there always has been um, an interest in what it is to be human as well, what makes us who we are, and whether there is a divine spark or whether actually we can be deconstructed and built up in some sort of analog through a computer. So I guess that's always
Yeah, that's
intrigued
that's
me.
an interesting perspective on it that I hadn't heard before. That you're trying to see how close we can get to real humanity. I mean, that's something we always talk about, right? We want to be able to have voice assistants and any kind of text to speech system be able to behave as much like a human as possible. But it does as we continue to progress down this path, it does raise that question of what is humanity versus what is synthetic. It's a really deep question that I don't think we're going to answer in this hour for sure. But uh,
No, half of me wishes that we never will, but the other half of me wants to
right,
burningly answer the
of
question.
course. Well, I will tell you, this is not one thing you should stop on. It's not time to stop yet. Let's keep going. All right, so I have another question, primarily based on your history. I mean, you talked about neural networks being around even in the 50s and 60s and how they've seen a resurgence. How have you seen the technology evolve? Like, what are the major advancements that you've seen since the early days in TTS?
Yeah. So I was really lucky. Well, I'm really, again, I'm using the
Right.
word luck, but I do feel very lucky or fortunate to have seen two major shifts in technology, really seismic shifts in the technology. When I was a young guy and I started in this, um, there were a few gods of people around, people like Dennis Klatt and Gunnar Fant and John Holmes, who were very famous at the time in their space. And they were working in a combination of hardware, software, with predominantly hardware because the computers at the time just weren't capable of emulating these things fully in software. That changed in the 80s when computers started to take off. And they were using mathematical models. And the models were they were relatively basic in terms of what they could achieve. And so the quality of synthesis that were produced by these models was less than perfect. Let's just put it that way. I mean, any model of life is an approximation, and the detail is what makes it life special, right? And so models tend to smooth that
Yeah.
out, and these things They were losing the fine granularity of what makes speech. So, but they were very, very impressive mathematical models all the same. But we'd reached this sort of plateau, a glass ceiling of quality. And I don't know whether it's because the sort of digital revolution was happening and cellular phones were coming out and people were thinking differently about the topic. There was this new thought. The thought was, let's not try and model speech. Let's see if we can just encode the speech and then stick it together and regurgitate it. I mean, I'm being very simplistic about it, but this was a radical idea at the time, and only really possible because of the emergence of significant computing power that allowed us to do it. But I was really there at the beginning, and I was fortunate to be one of the founders of this technology, which just transformed the ability of text-to-speech from something that was used only really for very niche applications. For example, helping people who lost their voice. The famous one, of course, being Stephen Hawking's. So they were used in that application, but they weren't used broadly in society. And then when these concatenative systems came out, they jumped the quality to a level that was acceptable to the general public. People say, oh yeah, that's a voice that I can listen to. And also the way the technology worked, we could sort of fool the system into being very natural for specific phrases. So it just shifted the whole game, really, from being an interesting side area to an area that could really influence everyday life with the interactive voice response systems that you saw in the 90s coming out. So speech synthesis took off. It took off through the 90s into the noughties. And of course, there were huge advances there. But again, we were cheating, right? We instead of having a model, we just decided to sidestep it by storing our lack of knowledge. Right. We just stored speech and said, well, we'll sort out the naturalist problem sometime in the future. And we got a long way with that approach. But we could see this another glass ceiling approaching, where we thought, boy, you know, we've sort of taken, squeezed the pips out of this idea, but we just had no real idea about how to take this technology further, and there wasn't really any clear signs that the models that were around were going to achieve that. And then neural networks re-emerged again as being a significant technology, and again that was coupled with increases in computer power, and that was the second revolution, where we could now think of models again instead of sidestepping these issues. We could think of modeling speech again using these neural networks, and that's just opened up a whole new world for us again.
So neural networks seem to be the path towards the future. That's where a lot of the, at least from my perspective, we see that in things like Amazon Polly and a number of other text-to-speech services. So when Alexa launched, and I know you weren't here at the launch, but was there a time at which Alexa was more a concatenative system and moved to neural, or is this something that's always been neural the whole time?
Oh, not at all. No, we in 2014 when Alexa was launched, the system was a concatenative system, and it was an extremely good concatenative system, as I will testify, as I worked for competitors, and I was always gauging how we were doing against how Amazon Alexa's voice was doing, and thinking, boy, they're good. So it's a great technology, but it's quite constrained. It's good at what it does, but it was fundamentally limited. So beating it was one of the challenges. Before you can release a new technology, it can't be any worse than the
Right.
current technology. And so that was our first challenge, was to actually demonstrate that we had another technology that could offer the same quality and also opportunities for the future. And of course, all new technologies bring their own challenges. It's never that you've got a completely new idea that's just slots into place
Right.
perfectly. The new technologies were heavier. They are heavier than capacitive systems, and there was a lot of scratching of heads to make them work. But yeah, we moved to neurals relatively recently, with the first launch being in 2018,
Got it.
if I
Got
remember
it. Okay,
rightly.
excellent. All right, so we're going to get back a little bit into your history. You mentioned that you were a senior lecturer at the University of East Anglia,
Hmm.
and you were talking about the research contract from BT that you had. But what you didn't talk about in your history was that you were actually doing a bunch of work with virtual reality environments too, right?
Yeah.
Tell me about
Yeah.
that. Like, I have like a few virtual reality helmets here in my house. Me and my family absolutely love the concept, and I can see a ton of practical applications outside of the games that we generally play. But tell me more about what you were doing with VR.
Yeah, it was pretty cool stuff, actually. It was great fun. There was a fashion at the time to have these virtual reality cubes where people would step inside and be surrounded literally by walls of screens that would display virtual environments, or there would be sort of convex walls that wrapped around you, and you would display reality onto that, or virtual reality onto that. And we were in that camp, so you had a big wall, right, a huge wall that wrapped around you, and you were surrounded by speakers that spatially, place the sound spatially around you, and the idea was to play around with these ideas of again, what it means to be independent as an AI, but in an entertaining way. And so we wanted to play around with distributed intelligence, intelligence that could learn from its environment. And the theory was that we real world is too complicated. It's just too complicated to try and to capture everything. But if we simplified the world, if we created a world where an AI could live within it and actually practically know pretty much everything there is about that world, could that agent then start to learn things and interact with a human being? And one of the things we did, for example, was the human being would play a game of hide and seek where you'd run away and hide behind a pillar, and the agent would have to search the environment and try and find you. And it was a great thing to debug because you'd see these rays of I don't know, virtual light coming out from the agent and then hitting a wall and coming back to the agent, and so you could actually see how it was mapping its environment. And of course, the human being would communicate with the world through natural language. So you'd say, go to room 5 or take me over there, and so it was combining all sorts of funky
Wow,
stuff.
that's super cool. I've had a decent amount of experience with virtual reality, and it's just been the way that it can immerse, and the idea of applying AI to that is really quite compelling. To be able to have even a simple game like hide and seek, I think being able to play something that is so traditionally human with something that isn't is that's exciting to me. And I know that was a while back, but still, those kinds of concepts still really haven't found their way into the commonplace experiences yet today. So I'm looking forward to the future and where that all lands.
Yeah, it's great fun. Of course, we had about 10 computers and specialist
Sure.
hardware. You could probably all do it on a phone now.
Yeah, I was actually wondering when you were first doing all this stuff, were you running a lot of your models and things on computers the size of houses?
Well, we know because we were going down a different route where everything was about distribution.
Okay,
So instead of having one big computer, you specialized a computer to a particular area,
got it.
sound, vision, whatever, and so we may have like 5 or 6 computers running simultaneously, and then there was this ludicrously complex software that created a sort of virtual software environment, coding environment, where it appeared that all the systems were in one
Interesting. But
place.
it was
So
using the processors on each of
you,
them
you just
independently. Nice.
yeah.
Oh, that's very cool. You've had some incredible experiences. So
Oh,
we recently had Gokun Tur on here, um, and he was able to talk about some of the new Alexa capabilities related to turn taking and for the ability for customers to teach Alexa. And we also had at our devices event in September, I know that we had some folks on talking about speech-driven advancements. Can you talk to that a little bit? Tell us more about those topics.
Yeah, sure. So, as I mentioned to you, the first thing is to make sure that you're natural, right? You have to sound natural, but that's a very vague term, and we sort of constrain the term natural to allow us to make progress in it, but it's a pretty broad sort of speech, and it was a broad sort of speech because that worked, and we wanted, but it's never going to really go where we want it to go because human beings, as we were talking about, what is it to be human? Well, one of the very human things to do is to associate what it is to be human with voice. And it's so full of nuances with the way we speak. We express so much through our language and the words we use, the way we say them. That this is obviously where we want to head. And traditional text-to-speech systems would analyze text. They would say, okay, here's the text, I want to analyze it, I want to extract knowledge from it, and then I want to synthesize that. And that's a really challenging problem in itself. Don't get me wrong, it's a hugely challenging problem. But of course, the other aspect that we work on is dialogues. So you want to be working and talking with an agent. And what we've recently started to look at is making our systems what we call contextually aware and adaptive. So, in other words, when you have a conversation with an agent, you want to be able to be adapting the synthesis to how the discourse is going. Just changing it subtly so that the way you respond gives the interlocutor the sense that you're hearing them, that you're responding in a way that makes sense for a human being. So we've been looking at adjusting our speech, the tone, the stress on the words, how we pause, even emulating how we breathe, anything that makes it sound more natural, without trying to fool people. We're not pretending as a human being there, but we want to cue into what's natural for human beings. Applying that to systems so that we can change as the dialogue progresses.
Got it. Very cool. So I want to know a little bit more about this. So we have this concept of neural text to speech, and what you're describing is kind of neural text to speech synthesis. Let's just start at the beginning. Can you talk about the foundations of neural text to speech first, and then kind of lead into how synthesis changes that?
Sure. So it takes us back to concatenative synthesis, I guess, and how that started. So concatenative systems existed, and there are another class of systems that let's call them parametric systems, or systems that again come back to having a model. So you either model or you encode. So these are the two basic approaches. If you model, right, you have a set of parameters. You push the parameters through your model, and it says something. But as I mentioned earlier, the challenge with these models are that you could change the parameters in any way you liked, and so it was very flexible. You could make a squeaky voice or a deep voice. You can make it really fast or really slow. But what you can never do was make it sound completely human. It lacked that knowledge to be able to convert the model into something that sounded very human. So we always had this ceiling of quality, of what's called segmental quality, as well as other types of quality, which are called prosody. So two types of speech. Segmental quality is the actual sound that comes out of E's, the A's, the O's, and the prosody is the rhythm that goes along with it. So we were lacking the ability of these models to be able to really get the fine quality out of them.
So I want to interrupt you for a second. This is incredibly interesting, but you prompted a question in my head, which is that it didn't sound entirely natural. How do we in the science world, how do we define natural? How is it just something that you have to subjectively observe, or is there some way, or is there some amount of measurement you can use to say this one sounds human, this one doesn't?
Oh, I really wish I hadn't asked me that question. It's such a hard question. What is
Right.
natural, right?
You don't have to answer that
And
question if it's too hard. I know it's a big
No, no, it's
question.
fine. It's just such a difficult one, and there are analogies in other areas, right? So, um, natural is a very subjective thing for a start. I mean, you've probably heard of the gap. I can't remember the name. The quality gap that is commonly mentioned. That you've got something that, as it approaches human-like, it suddenly starts to look slightly
Yeah.
eerie. So. When you've got AIs which are human close in terms of the way they look, when talking heads, people often complain because they look slightly dead, they look slightly
Right.
creepy,
That uncanny valley.
and the uncanny valley. Thank you. I couldn't
That's
find
right.
the word, and you just found it. The uncanny valley is exactly that, and you have the same thing in speech. That it just doesn't sound right. It's not hitting. The brain is hardwired probably to look out for certain acoustic cues, and if as a human being you do it without even thinking. The speech contains all the information at the right time in the right way for you to decode it as efficiently as possible. And and this is a side point, but very interestingly, one of the things people always say is it's robotic. Well, it isn't, because if you think about Hollywood robots, the one thing about Hollywood robots is you can understand them. It doesn't matter which robot they are, you can always understand them. So the actor, of course, is making sure that the information gets across the other human being, but there's a veneer of alienness that they put on it. They may make the pitch a bit flatter, or there may be some sort of reverberation applied to it. But because it's a human being, all the right information is there. When you actually go to the real world and you're actually trying to get a computer to do this, it doesn't have that. And so it can do things that will really unnerve a human being, or just not play right, or put a mental load on people that means that they have to slow the voice down because they can't quite understand what it's
Yeah.
saying.
Calling back to like the Stephen Hawking voice, right? I mean, it has that same property where like you are very aware that you're listening to a computer generated voice, and it is hard to listen to for a long period of time because you can't follow, and there's no beats, and there's none of the stuff that you have naturally. That's incredibly interesting. All right, so I interrupted you. You were talking about neural text to speech, and I want to get you back to that. I had to ask that question. Thank you.
Okay. Okay, yeah, I forgot what we were talking about as well. So there was the model approach, and the models always lack this something extra. And then we talked about the concatenative system, which is just about encoding sounds, and it's much more complicated than that, of course, because um, you can record sounds, and going back to why the first speech that was produced with concatenative systems sounded bored, is because we were trying to trying to reduce the number of variabilities in a voice. So if we just said to the voice, just sound the same, whatever you're speaking, and talk to you like this, and then we can actually then cut bits of sound out from anywhere, and then put them somewhere else. If each sound has got a high emotional content to it, it's stuck in that emotional environment. If you take the emotion out, you can stick it anywhere. So the neutral, slightly deadened voice was because it allowed us to move sounds around without that penalty. But of course, you still have to be able to select the right sound at the right time. And so the concatenation systems are really all about, how do I record the right sounds? What's the minimum number of recordings I can get away with, because it's expensive and time consuming to do, and which is the right sound to select at the right point for the synthesis. So it's all about selection, and we did start to move towards hybrid systems that use neural technology to select sounds, but it was still limited by what you'd recorded.
Sure.
And then there was these emergent technologies around deep neural networks that appeared around about 2016, and they demonstrated that the latest neural models could be used to generate sounds again. So going back to generating sounds in a more general way. But they were also able to capture and regenerate this something extra, this element of quality in human voice, that we weren't able to capture with the early models. So all of a sudden, we now had a mathematical approach, if you like, a model approach that promised to be able to do all the things that our older models had done in terms of flexibility, and yet potentially seemed to offer us this quality that was lacking before. And that was the big breakthrough, and where we've started to capitalize on.
And so, just for the people that are watching, is there any examples of how we're capitalizing on that, or how we're making use of that in ways they may have seen or heard?
For Alexa, yeah, for sure. The first thing we did, of course, as I mentioned, was that we had to demonstrate we were as good as, and that was the first thing we did, and we did that. It took a bit of time. The empty piece of paper is always the hardest thing. You know, once you've got something down in it, you can start to clean it up. And once we demonstrated that, we then wanted to ask the question, well, what more could we do? And so actually, one of the first products we produced wasn't just this natural flat voice that had been available for all the years preceding with catheter technology. We asked the question, well, what can we do different? And one of the things that came to mind was, well, how about seeing if we can replicate a style of speaking? So one of the key areas that people always think about when they think about text-to-speech is news reading. Oh, yeah. So, well, how about we see if we can get one of these systems to learn what it is to be a newscaster, to pick up the newscaster-ish global style, if you like, you know, of speaking that way. And so that's what we attempted to do. We trained the system on a mix of neutral style voice, and then injected into that recordings that we said to a voice talent, okay, pretend you're a newscaster, pretend you're going to read the news, and so we injected in that material as well, and then we taught the system to recognize the difference between the two. And then when you wanted the system to speak in a newscaster style, you gave it that instruction, and it said, okay, I should be speaking like this now. And lo and behold, we were pleasantly surprised to see that it did capture this property, and we were able to launch with the newscaster style to read a newsflash or flash briefings, which was great.
That's been a lot of fun to play with. So it's cool to see how all of this science and research and effort goes into making something that can be so impactful to a lot of people, and they don't necessarily think about how that all works behind the scenes. But synthesizing a newscaster voice can't be easy. I've got to imagine that there was a lot of work that went into just capturing that one kind of speaking style.
Yeah, we took a bit of time to get it right. One of the problems is that if you say to somebody, act this, unless they're an extremely good actor or actress, then they are unable to do that, right? Sure. It's gonna come across as fake, and we didn't want the sound of a fake newscaster. We wanted the sound of a real newscaster. So we took a great deal of time with the actor to allow them to get into and understand in their own mind what it takes to speak in that style. So they probably went through the same thing as our machines did. Right? They actually probably socialized in their neural network how I should be thinking when I speak as a newscaster, and they generalized that. They sort of turned that into something that they could reproduce, and so they could reproduce it. And since they could reproduce it, we could discriminate them doing so, and then we could teach the machine to do the same thing, which is what we did. But we took a long time making sure we got the real sense of newscasting.
Yeah, that's fantastic. All right, so we've talked about neural TTS and some of the techniques and technologies. How has Alexa's TTS become more advanced over time?
Well, so there are different stages that I think we've gone through. I've mentioned already that the first thing to do is to become more natural, right? And that's day one of the new world. Day two is saying, okay, well, let's see if we can apply some styles to it. Let's see if we can capture broad sweeps of a particular way of speaking, and that worked. So that worked pretty well. And then, of course, the natural extension from that is, well, style is what is style? It's difficult to pin down. It's a way of speaking, but of course, expressivity or an expression of motion is also very important. And we're often asked, well, can the synthesizer apply a particular emotion? So the next thing to try was saying, okay, let's see, can these systems learn an emotion? And so we did a similar sort of approach where we got a voice actor to express emotions. And then we took a slightly different tack here. We did tell the system this is emotion A, this is emotion B, but it was at a very high level. And then we used a technique called disentanglement, which allowed us to then build up a sort of what's called an embedded space of a representation of emotion in this space. And then you can navigate through this space and put a point there and say, what does that sound like? Oh, it sounds like you're really excited. Put a point there. What does that sound like? Oh, it sounds like you're really depressed. So you are able, once you've got this space, you'll be able to navigate around it, and then you'll be able to delimit areas that clearly represented an emotion to a human being. And so once we had these areas, then we could tell the system, all right, I want you to be in that area when you speak. And lo and behold, then the voice would actually sound happier because it was drawing its knowledge from this embedding space in this area.
That is so cool. There's something else I want to get to. There was a interesting publication authored by the members of your team. Actually, it was accepted at I think there's a conference this week. Interspeech 2020 is this week, and it's related to singing synthesis. This has really intrigued me. So, using computer models to synthesize a human singing voice. I mean, I like to think of myself as an amateur futurist and think about what the world will look like in 10 or 15 or 50 years. And as I read about this, I was just so perplexed by the idea of computers being able to not only sing, but potentially compose entire songs with lyrics all on their own. So I'd love to know more about what the advancements look like on speech singing synthesis.
So that was as you're right. There's a paper on singing synthesis came out in Interspeech, which is happening around about now. Many of the techniques are very similar. So the way, if we take a step back, the way that we've approached a lot of these problems is we've broken the problem into two parts. And the first part is it's about taking a knowledge source, text, or it could be sheet music, and then extracting from that knowledge source all the information needed, all the information contained in it, and then representing that in a vector or vectors of extracted knowledge. And that's called encoding. That's an encoding phase. And then once we've got that extracted knowledge, we then apply that to the second part of the first part, which is to take it and translate it into another representation. So this is called sequence-to-sequence modeling. And probably the easiest way of describing it is in terms of language translation. So you've got one language, French, and you want to convert that language into English. So you suck all the knowledge out of the French sentence and you store it in a representation. And then you take that representation and you decode it using a model that's been co-trained into a sequence that's English. And it does feel very magical that you can do that, but this squeezing knowledge and then expanding knowledge is called sequence-to-sequence modeling. And that's one of the tricks that's commonly used for all our modeling techniques. And in singing synthesis, as I say, we would take the score and the words, and we take that in, and then we would use that as part of the input sequence, and then we would decode that to the decoded sequence, which is then used to generate speech. A critical aspect of this is something called attention. These techniques of encoding a sequence and then decoding a sequence really only work well when you can attend to the right bit at the right time. So the analogy that's often used when you think about attention is to imagine a human being looking at a picture. You don't look at the whole picture at the same level. You'll attend to different parts of it that are important to you. And there's an analogy in acoustics where you want to attend to the right bit of knowledge at the right point in the acoustic decoding. so that you get the right sound out. And so this is one of the critical things that the paper has posited, that by using attention, you don't need other bits of information. You can just go with the score and the words, and the network is able to deduce from that the other information it needs.
Wow. All right, so singing is interesting, and it sounds like it's the next evolution. It's just adding more data to your training. Um, what about something broader? I think a lot of people probably are familiar with Samuel L. Jackson's voice on Alexa. Um, TTS is obviously a key part of how all of that works. Was there any I guess there were some recent advancements in that. Is that something you can talk about?
Sure. Well, obviously, customers love the Alexa voice, but they also love to play around with other voices, and we've known this because we've had things like jokes with Jimmy Fallon and Chelsea Handler, I think, did a duet with Ed Sheeran and so on. So we know that these things are things that people enjoy, and we had an opportunity to create a Samuel L. Jackson voice. Which we knew would delight customers, and that was launched. And in fact, in September, we actually advanced on what the initial launch was, because we're always trying to deliver what the customer needs to make it an experience that they're going to enjoy. And one of the things we discovered was what people really wanted to be able to say was, "Hey Sam, just go straight in there and start to talk to Samuel L. Jackson." So we've just launched now a new wake word so that you can go in, and instead of having to say, "Alexa, may I talk to Sam?" you can actually just say, "Hey Sam," and Sam will read back things like weather and jokes and more. So we just updated that, and it's a very exciting and entertaining
That's
area.
great. So anybody that has that skill, because that was a skill you had to purchase, as I recall. If you have that skill enabled, you should be able to just say, "Hey Sam" to your device, and it'll pick it up. Do I have to do any configuration or settings with that?
No, just to go, "Hey Sam." Once it's set up, then it's all
Great.
good to go.
Well, as soon as I get off this, I'm going to have to give that a try. I didn't realize we could do that now. I've played with Sam a little bit, but I haven't been able to call him up just that way. That's wonderful. All right, so looking forward, which is not something I get to do terribly often on this channel. What does the next evolution of Alexa's voice look like? How do you continue to improve it? How do you make it seem more human? What are the steps that we're taking to try to accomplish those kinds of things?
Yeah. So when we speak as human beings, we speak for a reason. It's a communication channel. It's about giving information to somebody or giving a performance to somebody, but we speak for a reason. And so behind every style, every emotion, there is a motivation. There's a reason for it. And as I mentioned to you earlier, reasons change from second to second depending on how your conversation is going, depending on what information is given to you. So we need to always think about what's motivating the reason to speak, and that requires us to extract knowledge from information from text. So, for example, if we're reading a news article, we need to be able to extract the intention of the author of the article, so that we can pull out not only the style but the meaning behind the style, about what's important, whether it's a happy event or a sad event or a challenging event. We want to be able to pull out that meaning and speak it in a way that is fluid and natural and gets across the right meaning. And as I said to you, we're thinking of contextual awareness and adaptation. It's about being able to extract that knowledge and then apply it back in a way that engages with the user from a dialogue perspective, or if we're just reading back knowledge as well. So it's about being able to move forward and adapt to the environment, to the person, and to the context.
Awesome. All right, last question before we wrap up here. I can't believe we only have 5 minutes left. Besides the adaptive speaking and emotion stuff we just talked about, are there any other customer-facing improvements, maybe things that people have an Alexa device that may be familiar with? But is there anything specifically that you've worked on that you're the most proud of, something that's really impacted our customers?
So it's early days. in this new world. And there's so many ideas we've got. And the one I've pretty much expressed you the big picture about where we're going with adaptation and context awareness. And I think those are the new frontiers, being able to get this sense of knowing and being aware through the voice. But the thing that I've been proud of, I think, in this first 3 years is taking the team, and it was a team of, obviously it's a team event, a team activity, and there were real hurdles that we had to get through to get this new technology up and running, and we've been heads down, running as fast as we could, just to stand still really in terms of this technology, because it's such a fast-paced area that I think I'm really proud of just getting the neural technology out there, that just getting it out broadly to people. With the quality that we've achieved, at the technical cost that we've achieved, because it was an expensive technology. You required GPUs and all sorts of hardware. So we've had to scratch our heads and work really hard to keep that quality high while making it cost effective, so that we could actually get it out there broadly to our customers. And that was a great ride. So that's probably what I'm most proud of at the moment.
Excellent. So I want to note that I know there's been a bunch of interesting blogs that cover specifically the Alexa speaking style adaptation that you've been talking about, as a bunch of other science advances that were announced last week on Amazon.science. And I think we've got a link actually to some of the related TTS content that's on Amazon Science, and we're going to drop that here in the chat. If you all watching here would like to learn about these announcements, about what Andrew and the rest of the Alexa Science teams are doing, or even some of the scientific endeavors going on across Amazon, please check out Amazon Science. We post all sorts of information there, including these videos and these recordings. So if you'd like to know more, Amazon.science is definitely your destination. So with that, Andy, I can't thank you enough for taking the time this morning to share your perspectives on this. I know I learned a lot, and I'm sure that our audience did as well. Do you have any parting thoughts or anything before we head out?
No, I'm completely blank at the moment.
Perfect. Well, as my name is Blankenberg, I'm consistently blank. I completely understand. Well, I want to thank you again so much for being here, and thank the audience certainly for tuning in. And we will talk with everyone again soon. Thank you again, Andy.
Thank you.
Bye-bye.